Good morning, good afternoon, good evening, and welcome to our very special Call for Code for Racial Justice mini-series here on Red Hat Live Streaming. I am Chris Short, host and showrunner of all the things on this channel, it feels like sometimes. But I'm joined by the wonderful team from IBM working on Call for Code for Racial Justice, and I will hand it off to Sabine to do the introductions and such. Thank you, Sabine.
Awesome. So can we actually go ahead and start sharing the screen? But welcome everyone. This is another series, or not another series, another episode, I guess, from the mini series that we're doing around Call for Code for Racial Justice. And it's been very exciting, going through the solutions that we have in open source right now in partnership with the Linux Foundation. And so today we're highlighting the Lines of Justice, which is the team that you see before you, along with a couple of other members for the solution Incident Accuracy Reporting System. So we can go on to the next slide, but just welcome everyone. So in the past, I haven't given a whole lot of huge background on Call for Code or even, Call for Code for Racial Justice, but I really wanted to, level set, especially at this time, because Call for Code as a whole is a program that exists outside of IBM, and is hosted by David Clark Cause, and IBM is really the founding partner of this initiative and provides really the technical expertise alongside, the Linux Foundation and United Nations Human Rights. So this year we actually have, our annual competition, which is coming to a close, and focuses again on, tech for good and being able to develop open source solutions that are supposed to support communities in need. Next slide. So it really focuses on inspiring and motivating developers to upskill themselves and to use applications specifically to solve some of the real world problems, that we're seeing in society. So the projects right now, again, are open source, and the focus is that everyone should be able to access it. But again, being able to use, different technologies to kind of critique how the problems can be solved. And we're really excited to, show what that looks like on the next slide. So Call for Code, and this also really, speaks to our community as a whole, is around being able, again, to produce solutions that affect communities in need and the priorities that we see. But it also is really emphasizing how can you build skills around development? How can we engage community members? Sorry, my dog. Engage community members to want to participate in this work, but also collaborating with them so that they can, be a part of the solutions and taking ideas into action. So most hackathons, or even, typical hackathons, focus on, all right, we're giving you this, use case, go at it. We're going to give you maybe a week or, a couple of days, and, best of luck. It's not just about being able to produce a solution. It's saying at the end of this, how can we actually implement this in the world as it stands? And so for this year, there's a $200,000 grand prize that comes from the global challenge, where if your solution is selected, you are able to actually build it out along the right type of supports with IBM and a couple of other partners that we always have on hand. Next slide. So submissions, again, are coming to a close July 31st. If you have been working on a project already, get it really geeked and excited to submit it. And you can explore how you submit your application right now. But we really want to just focus, again, this session is on climate change. And you should be able to register in the steps that you see below. It's pretty simple. We've given you 3 of them, and you should be ready to participate. All right, next slide. And to give a little bit of a timeline of how we got here when we're talking about Call for Code as a whole, and then where Call for Code for Racial Justice falls in there, is in 2020, exactly right there, where we see 7 open source solutions that were created by IBMers and supported by Red Hatters, in June of last year, where we had this call to action to say that we wanted to use our strengths and our skill set as technologists to address some of the systemic racial inequities that we see within our communities. And so if you go to the next slide, you'll get a little bit more of an understanding of how we got here and what are kind of our guiding principles or pillars, as we'd like to call it, for this period of time that we were in. So we have police, judicial reform and accountability, diverse representation, and policy and legislation reform that really help to frame how the solutions that are, in the series right now, as well as, further ones that are being developed, really are addressing some of the critical needs within these segments. And so incident accuracy reporting system actually falls within police, judicial reform, and accountability. And we're excited to share a little bit more of an overview of the solutions that are to come. Next slide. So here we are. So far, we have been able to see a couple of our previous solutions, and right now, again, instant accuracy reporting system is a platform that allows for collaboration and corroboration for witnesses and victims who have evidence during a police encounter. And we're going to dive right into it. I'm not going to try and do it any injustice by giving you a quick summary. We're going to have a really good deep dive by the rest of the team, and they'll also be able to introduce themselves as we're moving further, so you can see, yes, we've been working. This is actually I don't even want to call it a volunteer effort, but an active project that everyone on this call is working on in addition to your day jobs. And if you know anything about the work that you do in your daily life, especially in tech, it's a lot. So definitely want to congratulate and always thanking the team for their committed dedication to this project. And I think that is all of the talking. I'll probably interject with some more questions, comments, and clarifying statements as we move through here, but I'm going to go ahead and hand it off.
All right, thanks, Sabine. Hi everyone, I'm Shonda Witherspoon, and I'm going to start off on the presentation for our Incident and Accuracy Reporting System, abbreviated as IARS. So before we get started on a solution, I want to give a background to the problem statement and motivation that got our project started and implemented into an open source solution. So the motivation began with the recent reports of police interactions with the Black community being featured prominently in the news. And often, unfortunately, these features interactions have been tragic. So according to the Washington Post, since 2015, Black Americans have been killed by the police at more than twice the rate of white Americans. And some of these incidents have even been captured on video or witnessed by civilians. However, what we notice, of course, due to the recent media reports, is that despite some of this being captured on cell phone cameras, or some of these incidents even being captured by the officer's own equipment, like their body camera or their dash cam footage, we see that incidents and information surrounding this isn't always reported as witness, I should say. So let me give an example. So what you see on the left-hand side here is the original press release for the George Floyd incident. So what we see here at the title is it says that a man dies after medical incident during police interaction. And when it gives the details about George Floyd's encounter with the Minneapolis Police Department, it doesn't mention anything that we saw captured by the cell phone footage. In fact, the last thing simply mentions that no officers were injured in the incident, but doesn't give any details about an officer's knee being on George Floyd's neck for over 9 minutes. So unfortunately, when we see these kind of things, we're wondering, well, what exactly goes into the final police report that is given by the police, and ultimately, how do we have information that is contradictory from what was actually captured from the final police report? So this has left many people asking for transparency on how incident reports are even generated, and furthermore, the accuracy of those written reports, as ultimately only officers have the final say-so over what's captured in the report. So after last summer's call for code for racial injustice came in, we all decided that we wanted to answer the call and be able to tackle issues just like this. So this is the members of our team. All the members, unfortunately, aren't here today, but the ones that are here, I think we can all introduce ourselves. So starting myself, highlighted, this is myself, Shonda Witherspoon, and I was a user researcher on this project. So I was tasked with being able to do interviews with police officers, police complaint officers, and various members of the police community in order to get a better understanding of how incident reports were generated and how our system could be able to handle the correct pipeline and develop a solution that would be able to add some transparency and validate accuracy that goes into a police report. I'll pass this on next to my twin, Shalisha Witherspoon, that you see her highlighted. So Shalisha, could you introduce yourself?
Yes, hi, I'm Shalisha Witherspoon. I also contributed on the project. I assisted as a system architect and also helped with user testing. So I helped with designing diagrams for the components of the system, as well as seeing how users can interact with a prototype of the application.
Next, I'll pass it over to Abiola, highlight here in the PowerPoint. So Abiola, can you introduce yourself and your role?
Yes. Hi, everyone. I'm Abiola Ashuju, and I worked also as an architect, coming up with the components of the system and doing some block diagrams in the beginning. And that's pretty much it.
Thanks, Abiola. Next on the side of Abiola, between myself and Abiola, is Tunde.
Hi, my name is Tunde Olokudano. I worked as a developer for this project. I developed the AI backend of the incident accuracy reporting system. So basically, that's what I did.
Thanks, Tunde. And then finally here today from our team is Laura, highlighted here. Sorry, my apologies, Lucia.
Hey everybody, I'm Lucia Ramos. I am from Uruguay, and I was the user experience designer for the project.
Thanks, Lucia. Sorry about that. But my mind went to introducing at least the other members who weren't here today, starting with Laura. She was one of the developer advocates on our team that was provided to help us with our solution. Next, we had Kalanji, who was also a developer advocate and worked on many aspects of getting our solution developed and coded. Here we have our leader, Osai. So he's responsible for the team meetings and having everyone organized, presenting weekly on our progress to the Call for Code team, and getting feedback that we could work on through each week's iteration. And then finally in our team was Deborah. Deborah's role was a generalist, which means that she worked on whichever aspect that we needed help with. So if we needed assistance with user research or working on diagrams, then we could rely on Deborah for that. So that was our team, Lions for Justice, for the Call for Code. So next we had to decide on a theme that we would tackle. As I mentioned in the first slide, we wanted to tackle police and judicial reform and accountability. So we wanted to get some insights on how we could improve the current process of what goes into making a police report or an incident report. And because of the lack of transparent and accurate data available to assess police behavioral infractions, then unfortunately we want to deal with the inaccuracies that can be born from these reports, or any falsifications that could in theory be made without cross-reference or any accuracy checks. So this led to us developing HILS, which eventually turned into solutions, which is the following. We want to make a way so that internal affairs and civilians, such as witnesses, could both contribute to incident reports by creating a tamper-proof record with all accounts of the incident. So this basically would allow civilians who have cell phone cameras or witnessed an event to be able to contribute their own evidence to a police report. And then we could provide a 360 perspective of clean data to assess the police report and be able to highlight any inaccuracies that may be written in the report. That way, internal affairs or chain of command could properly assess police reports that contain any inaccuracies. So that's how our incident and accuracy reporting system was born. So I'll pass it over to Lucia, who will explain more details on our user research and our final solution UI. Lucia?
Thanks, Shonda. If you can go to the next slide, please. So to start our project, the main goal was to do user research. And first of all, to understand how the police works and how the incidents are generated. So we conducted a first-hand interviews, and they were based on our scenario with police complaint officers, dispatchers, and other members of the police force. This research allowed us to build the workflow of the reports. But also to understand the feasibility of our solution, we interviewed a police officer who used to work in internal affairs to see how our solution will work in the real world. And lastly, and the most important part, was to understand how civilians, victims, witnesses would interact with our application. Sorry. So we conducted user testing, surveys with volunteers to ensure that we were building something that was user-friendly, but also it was going to be used by people. Next slide, please. So with all that research, we went to design our solution. So we have a content management application that captures the statements, videos, audio feeds from first-hand individuals, all related to police reports. So we have an interface that it's for the individuals, the witness, the victim to report information or data related to the incident. And then we have the manual or automated flagging that is for inconsistencies and inaccuracies that are in the initial reports based on all the collected data. Also, it cross-references the report data with the officer history on misconduct, and a backend to a blockchain instance that has the actual document stored in an object store. So you see we have like a mobile version of our web and a dashboard for the police officers or supervisors. Next slide, please. So how do we picture all these things flow together? We imagine that a victim calls 911. So PCO questions about the emergency, asks of what they saw, what happened, and if there is any missing information in that part, it's going to be reported. And the recording is all going to be uploaded to the system. Then when the police officer arrives to the scene, they enter the information in the computerized dispatch. When the police interviews the victim and the witnesses, they take notes and also records information in that system. Everything, the recording, the notes, what it's uploaded in the computerized dispatch is going to be uploaded in the system. So lastly, the systems with all the upload information is processed. And for instance, if the interview with the witness conflicts with the written report or any inconsistencies are shown, this is going to be sent to the supervisor or sergeant. So the alerts are shown in the dashboard, but are also sent by email or other things. And this allows us to present all this information to the people that can do something. So this is how we imagine the workflow of our solutions going to work. So this is what we wanted to show, the history of how we ended up with our application. And now I'm going to leave Abiola to explain a little bit more about architecture.
A comment / question around this, especially in developing this workflow. How did the previous, interviews that you did help to frame this? Did they get to see this? Was this, really validated by the information that they gave you?
I have Shonda that did the interview, so maybe she can tell us a little about it.
Yes, actually, so this was developed in many different iterations before we came up with this ultimate solution workflow. So first, I was able to interview with various roles in the Miami-Dade Police Department, as I mentioned earlier. And what they basically helped me work with was a flow diagram that had many different scenarios based on what happens when a person calls 911, how that leads when a police complaint officer takes the call and assigns it an incident number, what happens when an officer arrives on the scene, how is the incident reports written, etc. And after we went through those different iterations, I would speak to another member of the police department, such as a police dispatcher, who would add on to that work flow diagram. And once we had that information captured, I confirmed that information with a police supervisor, which ultimately led to the next step, which would be, once the report is written, how is the current flow diagram used in handling what might be considered an inconsistent report and where that might fall in the diagram. And after that iteration is where we came up with how our solution would fit in to change some of the flow when you have an inconsistency in a report, which is highlighted in the blue part here. And after going back and discussing that with another sergeant, then we would go back and reiterate over that until we had the final one here. So there was many different workflow diagrams that was created in part thanks to the officers at the Miami-Dade Police Department and their various roles that helped us to be able to come with a realistic solution from what they currently have to how our system would be able to add value to addressing these inaccuracies or any errors that might be listed in the report and flag them.
Awesome. Yeah, thank you for making sure everyone knew that.
No, and when we interviewed the police officer that used to be working, he's an IBMer, he used to work in internal affairs. He also explained to us what it was needed so the inconsistencies or the problems or the misconduct of the police officer could be tackled in real life. So we also knew that little bit of information to help our application.
Perfect.
Can we move to the next slide?
Yes, so moving on, we're going to go to the architecture where Abiola will go on to our system architecture and some diagrams with that. So Abiola?
Yeah, next slide, please. So I will be going over the block diagrams that we have in our architecture that shows the various pieces of our system. So starting off with the context model. So we came up with the contact management system, which will be interacted with by the victim, the witnesses, and additional sources of information. It could be from news reporters and law enforcement, and all of this information will be processed. So this is just a block level overview. So next slide, please. And then we have a draft high level solution, which shows a breakdown of what Lucia and Shonda talked about earlier. So you see how the witnesses would contact the police and the police would interact with the victim. The witnesses will interact with the police and reporters will submit information. And the technology that was used, right? So a victim will call, a police interviews the victims and witnesses. We process all of that data in our content management system. We store in blockchain. We use blockchain to ensure that the information that is stored is secure. And then we did some post-processing before storing the information, right? Like if it was a call that was logged in or video or audio, you would use speech to text to convert that, or language processing if it's non-English. So this was just a high-level solution that we came up with. And then moving on to the next slide, it shows the flow of how this would work, right? So a user would input information into the system. documents, audio, video. This video, audio is processed, like I mentioned earlier, speech to text, language translation. We used the technologies we used, open source technologies like for blockchain, we used Hyperledger Fabric. IBM technologies, Watson speech to text. And then the machine learning, we used also some open source technology. And for everything was stored in cloud, would be stored in cloud. Now we would validate the information using the machine learning, right, as mentioned earlier. So the documents that are inputted into system, if there are inaccuracies, for example, if the officer did not put in enough information and a witness called in, since they have access to upload information into the system, those will be cross-referenced, right, using the machine learning, and you see if there are inaccuracies. So moving on to the next slide. This also shows an operational model where a witness or victim, how they engage with the system, right? Interacting with the police, calling directly to log information into the system, uploading their video or audio, and then the technologies that were mentioned earlier. So this shows a high level of our system, operational model wise. And that should be all of it. Next, we'll have the demo, unless there are any questions.
All right, thanks, Aviola. So I'm gonna play a demo recording that was done by our developer advocate who couldn't be here today, named Kalanji. So let me start the demo presentation.
I'm Kalanji Bankoli, and I'm a developer advocate with the Emerging Technologies team. So today I will be demonstrating the Lines of Justice project. So what we have here is a dashboard that can be leveraged by members of the police force at varying levels. So whether they're a officer in the field or a detective or a supervisor. And this dashboard gives an overview of all cases that have been received by a particular police station, as well as any associated evidence such as audio and video files. And we also have visualizations of how many reports and complaints have been submitted over time, as well as a breakdown of their status. So the main purpose here is to essentially compare police reports with accounts from witnesses and victims and compare how similar their descriptions were. Afterwards, we then categorize the reports based on how many conflicting descriptions were detected. So if I go on and navigate to separate view, so this is a different section of the dashboard. So essentially, this is a witness report form. And basically, this section will be publicly accessible and allow for anyone to report a particular incident they may have had with a police officer. So they can specify the location, the officer name or badge number, and they can describe the incident in their own words. They can also upload files in this section. So for example, we'll go on and drag and drop an audio file. And then I can go on and click submit. So after clicking submit, then the audio file will then be transcribed through the Watson speech to text service. And then we can also see details for each report. So we can see the transcript, and then we can also, and then also in the background, the raw file is stored in the IBM Cloud Object Storage Service. So essentially, we will take a hash of that audio file and store that hash and all associated metadata on a blockchain. So if there's any case where the original file is at all tampered, within the cloud object storage section, then that hash wouldn't match anymore, and that would raise a flag. So anyway, so that concludes our demo, and I hope you enjoyed watching.
So moving on from the demo, we will go into the technology of what allowed our solution to be realized. And for this, we'll have Tunde explain. Tunde?
Tunde, you're on mute.
Yeah, thank you. Yeah, thank you, Shonda. So
Yes.
Let's go to the next slide, please. Okay, so these are the technologies that we used for this project. We have some IBM technologies and some open source technologies. The IBM technologies are the Watson speech-to-text, as demonstrated just now by Kalonji. And then we have the Watson language translator, because we could have witnesses who are speaking languages other than English. Then we also have the Watson Studio, IBM Watson Studio for the machine learning side of the project. Then we use the IBM Cloud Object Storage for storing our assets, you know. Then these are the open source technologies, the Vue.js for the front-end development. We have Docker for containerization. We have FFmpeg for video recording, video audio processing. Then we have blockchain to make the system tamper-proof. Then scikit-learn for developing the machine learning algorithm. Next slide. So the machine learning algorithm we used to analyze the witness statements and, as the case may be, juxtaposing it with the available police reports. The machine learning algorithm we used is called K-means. It's a kind of unsupervised machine learning algorithm, which will enable us to divide a host of data sets into clusters. And as you can see from this animation, you can see different clusters. And the process of identifying the data points that belong to the same cluster is what those moving crosses are doing. So those are called iterations. So what happens is that when we have all these statements submitted by the witnesses, so we want to bring them together, and we want to see if there are statements if there are witnesses that are consistent, that have consistent statements, you know. So in a particular location, there could be multiple events. So we want to identify those who are talking about the same thing, and bring them together. And when we identify those who are reporting the same issue, then we compare that to the police reports, as the case may be. So what's happening here is that we extract certain features from those statements, features that will help us to identify how similar those statements are. So we use a feature called TF-IDF, that's term frequency inverse document frequency. That helps us to bring the main important things out of those statements. Then after we remove the stop words, convert them to word vectors, and centroids are initialized, and the ones that are closer to a particular centroid will go to that cluster. So I believe I've explained that. If you have more questions, we can look at that later. Next slide. So here we see some of these things have been described by Kalonji. So we have a report, it goes into the database, then we identify those reports with matching metadata. What are the metadata collected? The date, the location, and probably the kind of incident that occurred. So when we see those, we bring them together, and then we put them into the cluster and see if their descriptions are also saying the same thing. So here, this yellow circle is talking about a cluster. Those events are talking about the same thing. Then we have these red circles that are close together. That could be, also another event that happened at the same time and maybe the same location, and the witnesses are consistent on that as well. So let's go to the next slide. So here we did an experiment using simulated data sets of witness statements. Those are not actual witness statements. We just use, those statements to simulate witness statements. And we got a sample police report, from an online source. And we, put them into the K-means algorithm that we developed. And, here we have like 2 different clusters signifying 2 different events. And here we have the police report standing alone outside of those clusters. So this tells us that the statement of the police is not, is far away from what the witnesses are saying. So the centroid of these clusters will be at the middle. That gives you an idea of how far the police report is from the centroid of each cluster. The centroid of the cluster is at the center. So, so this is an experiment. It doesn't mean that this is the way it is always. The police report could fall inside of the cluster, meaning that the police report is consistent with what the witnesses are saying. But in this case of this simulation, the police report, which we got, of course, was clearly not related to the statements, even by visual observation, and the K-means algorithm is confirming that. So with this, we can be able to, detect some of those inaccuracies in the reports submitted by the witnesses. And like Kalonji said, the statements submitted by the witnesses have been tamper-proofed using blockchain. So it cannot be, it cannot be mutilated or falsified after submitting it. So, yeah, I think I'll hand over to Shalisha now. Thank you.
Thanks, Tunde. So I'll be going over the next step we took and helping our solution be fostered by the open source community. So next slide, please. Okay, so what we initially we just did just earlier this year around I believe around in the spring, we had a series of design thinking workshops to help us understand potential adopters and contributors to our solution. So we worked with subject matter experts in different areas, such as the Axon. They are responsible for providing equipment to police officers, such as their tasers or their body cam. We also worked with the Office of the State Attorneys in Florida. And we also worked with the United Way of NYC, which is a nonprofit organization that's dedicated to helping low-income members of the community and building relationships between law enforcement and the community. So through design thinking, we worked with an empathy map to help us more identify with our adopter based on the help of the subject matter expert organizations. And in tandem, we also want to work on empathy map for our citizens, who are the other side of the users for our solution. So if we look at our adopter, which could be police departments, law enforcement, we have to identify 4 different areas, such as what do they say, what do they think, how do they feel, and what do they do. And so for summarizing, what we found when working with the SMEs is that maybe they may feel that this system could be expensive due to the AI that's embedded in our system. But they also would see that, of course, this could make the department more transparent. Then we want to think about how they feel. Some potential ways they could feel could be hesitant to trust, the civilian input, and then conflicted on this idea of making sides, such as inaccuracies between the police and the civilians. So what we think, we imagine the adopters would think would be that it could help towards investigations and make them more thorough through automation. But some other thoughts might be how to determine if the inconsistencies are from transcription errors, maybe not just from, intentionally done by their officers. And then one of the most important things to consider was the supervisors thinking, how can they convince the officers that this is beneficial for them and not a tool that's strictly used against them. So that way, law enforcement would be our main adopters. So we want to show them this is a tool that can help them clear out the inconsistencies that may be in the report, either intentionally or not, and can help them do this automation through internal affairs. That way, they can see that this tool would be useful on their end. So that's something we want to consider in our empathy map.
I have a question
yes.
around this. So how did you think about, especially when we're talking about and being inspired by, I don't know if inspired is the word, or being, I guess, prompted by the George Floyd incident, wherein the young lady who recorded the incident, was kind of attacked after the fact, right? Did you think about, how people who end up submitting evidence or are trying to, be upstanders in that sense could also, be protected, by a solution like this?
Yes. In our empathy map, that was definitely one of the highlights that we had considered. As I mentioned, this idea of the privacy being protected as they upload this information. Even when when me and Lucia did user research, that happened to be one of the many topics that came up with the users. They definitely enjoyed the system, but they wanted to know, the feasibility of being somewhat anonymous through their reporting. So yeah, I think that you mentioned a very important part, and that was actually, I think that was the major feeling that was captured in this in our empathy map, was just the privacy through the citizens. Will they be believed by submitting this report? Would this still be enough in order for there to be accountability through our system?
Right. Agreed.
So yeah, so very good question. I think this leads to our next slide and shows how we took that into account during our prioritization. Okay, so now we want to work on the prioritization, which basically lists on an axis the level of importance of some of the features that we want in our system, and then but also shows the feasibility of the proposed features and additions that we had in our MVP solution. So during this exercise with the SMEs, we came up with a few dimensions that we recognized that we took based on the empathy map. So what we have is we had data trustworthiness, we had trend and transparency, we had a trust for citizens, such as their data protection and controlling their data and their privacy. And then we had a trust for citizens regarding the truthfulness of reporting. We also had easy access and data upload for the citizens, and then the ability for these citizens to be able to track the incidents that they reported and get updates on them. Then we looked at the alerts or automation of their internal processes. So for example, if a report comes in and there's having notifications if there are inconsistencies, we want that, of course, to be automated. And then we want the ease of use for the police, such as, of course, seeing the value about this automation for internal affairs. But also, one of the big things we want to highlight, of course, that came from the empathy map was building the trust for police, so that they can see this tool, how this tool can benefit them, and once again, not be a tool against them. And then work on the potential of the cost savings based on the technology that's used that's not open source, such as the AI. So look at these prioritizations. What we found were the top three dimensions were the easy access and data upload for citizens. So for example, as you saw in the demo, what we had was the our prototype UI for the dashboard, and there you saw how we were able to have a citizen upload on the website the desktop interface. But we would like, of course, for users to be able to use a mobile application, and so that they can, record directly from their cell phones and then more easily upload that data to the system. So this all falls into easy access and data upload for citizens. The ability to record an app and be able to input their things right at the spot in real time. The next we had was a trust for citizen. So that's the orange blocks. And that's basically their data protection. So basically what Sabine had just asked about the citizens being able to have some control about whether they could be anonymous in this reporting or just some way to have this, the trust in having their data in the hands, I guess, of the police, of the law enforcement in their system. So for here, we thought about some secure identifiers for witnesses so that there's no PI. And then and then have login systems so that they can see, so we can see if anonymous reporting is feasible in some situations. And then lastly, we want, but also one of the most important is building the trust for the police. So for this, we looked at the idea of having clear AI explainability of why a report is inconsistent. So when we just have the flagging of reports and this sent to the system, we want to have the AI clearly list why the information was inconsistent, so a police supervisor can review this and then see what the AI highlighted and be rest assured that it wasn't due to something like such as typos or inconsistencies. And if it was, then they can clearly check that as well. So just not enough to just say, oh, there was an inconsistency, but clearly highlight why, to build that trust that they can trust the system. So please go to our next slide. So based on the part, I'm sorry, was there a question, Sabine? Okay, no problem. Well, so anyway, I'll just finish off by going through our roadmap. So based on our user adoption tests and our prioritization, we came up with this final roadmap that we're hoping to get help from the open source community and getting this implemented to improve our MVP and our solution. So based off the prioritization, we have the 3 different areas that we can help contributing. So the first we have is our mobile app upload. So as I just mentioned in prioritization, what we want is this easy access and data upload for citizens. So this includes the uploading their eyewitness accounts and any evidence through either Android or iOS, etc. So what roles so not only do we have the technical requirements that's needed for this feature, but we also have roles that we could use in order to get this done. So for example, a designer, app developer, and someone who's familiar with web design, for example. So they can help us to get this mobile app feature unload and help us get this ease of access for the citizen adopter. Another area that we could use that's doable for the roadmap would be automated notification. So as he mentioned, we want this process to be automated so that supervisors don't have to do the manual, investigation of false or inconsistent police reports. So for example, this could be email notifications that go on based on the inaccuracies and some threshold that's sent to a supervisor's email. And there could also be email alerts also given to the citizen based on any updates that happens through the investigation process, etc. So for this roles, we would like software developers to help implement this, but both on the mobile side and as well for the web application that's used by the red officers. And also, of course, we would need people from security to help us secure this information. And then lastly, this goes to we have the AI explainability and transparency. So for example, going off of the last example, which was building trust for police, we want a clear way of when the inconsistencies are done, how can we highlight specific areas of why the system flagged these inconsistencies or inaccuracies that were reported. So for this, we're looking at some details of our scores based on the calculation to use as a threshold. we're thinking of ways to make a link part of the recordings of where the error happened, or flagging the speech to text errors based on if it was simply an error in the system. So for this, we would like data scientists and machine learning, specifically natural language processing experts, so they can help develop this upgrade on the flagging system, so that we can have clear explainability for police officers to trust where the system is making an error, and it's not just reporting flags. So through these three areas in the roadmap, we're hoping that there's many different roles for different developers to get involved based on their expertise and what they're comfortable helping with. So hopefully, do things like this, we can get more contributors that can help make our system really strong, and then reach the phases of adoption. All right, so next slide. So this concludes our presentation. So you're able to join us through Slack, Community, IBM Cloud, and then we have a QR code that you can scan that should take you up to how you can get started right away.
Yeah, absolutely. And I really just want to kind of drive that point home. This is a collaboration with, folks that are, of course, within IBM, but we're really looking at this as almost like an outside or an outside in type of situation where we have the solution that was created internally. But we really are focused on how do we get people outside of our community or our immediate network of, IBM to really join us in refining these solutions a little bit more, being able to provide those additional supports as we are making this available for potential adopters, which is really important because we want to show that it's not something that's created in a silo. We can see that we've done, our due diligence in contacting community members, police officers, and understand kind of like the background and how a solution like this would be useful. But we're really emphasizing that anyone who wants to learn how to do, how to accomplish some of the items in the roadmap, there's opportunities for you to learn to do that through our community. And there's also ways for you to be able to teach. So if you have some of the skill set that are requesting, we really encourage you to contact us. Again, scan this QR code and it'll tell you how you can begin to get to know us a little bit more. You can join our Slack community. I'm in there. Demi Ajayi, who's our community manager, is also active there, as well as the rest of the team members. And we really want to be able to bring you in, collaborate with you, and then also show that, again, this is coming from a call for code to being able to be implemented into community. So we're really excited about it. That's all we have for today. I think the team, usually I peppered a lot more questions, but I knew that they were going to get to especially a lot of the thinking that went into creating this, which I think is always going to be the core to solutions that are really supposed to provide transparency and accountability. It's like, who have you talked to? How have we validated this? Is this serious? And yes, to all of those questions.
Yes,
Awesome.
Absolutely. Thank you, Sabine.
Mm-hmm.
Yeah, thank you, Sabine. Thank you, everybody, for participating in this project. It can help change lives, right? And a lot of outcomes could be different as a result of it. So please, I encourage you, join if you have time. If you want to get started in open source software, this is a great place to start. If you're experienced in open source software, this is a great place to continue. So I appreciate everybody that joined us today and demoed this project. I think it's very important to get more folks involved. So thank you for bringing this to to Red Hat so we could stream it out for everybody, Sabine and others.
I'm putting this on them. They did the work. So I'm just the person who helped to move the conversation along.
Thank you.
Everyone who participated.
Yes, and then lastly, all the roadmap that I mentioned, all the roles that we needed. In the coming days, we'll be adding those as issues to GitHub. So anyone who wants to contribute can clearly see how and what they can do to do it to make it more easier. So we look forward to as much help as we can get and new contributors to this project.
Absolutely.
Cool.
All right, handing it back over to you, Chris.
All right, folks. That's all the live streaming we have today, but be sure to tune in. If you're in EMEA, it'll be around 10 a.m. your time tomorrow for the open shift coffee break. And then when the East Coast wakes up, please join me for the level up hour at 9 a.m. Eastern. And with that, I will bid everyone farewell and see you all again soon.
Awesome. Thanks so much,
Thank you.
everyone.
Bye-bye.
Bye.